Battery and motor are like heart and lung of an EV. In the previous episodes, I have talked about battery. If you have not watched it, it's over here. Today's episode is going to be on motors. Hello everyone, welcome to the Green and Clean YouTube channel. My name is Vittal. Today's episode is going to be some sort of a back to school kind of episode. We've all learnt about motors in our school days. Maybe now is the time to just refresh it. Motors are nothing new. They have been in existence since 1821. I think it was invented in 1821. So it's already more than 200 years old. And every household already has motors in different forms, be it your fans, washing machines, dishwashers, toothbrush, and whatnot, right? So it's nothing new. It's just used in EVs also. And that's the context of today's episode. Before we continue, you would have done this at some point of time. You take a magnet and try to attract another magnet using it, or you just flip the magnet and see the other magnet just moving away with some force. You know, a magnet has two poles, north pole and south pole. Opposite poles attract and the like poles repel. That is how that is the basics of magnets. I'm sure every one of us know about it. Now let's take a look at this diagram. So we have two magnets here on the left hand side and the right hand side. If we place this magnet in such a way that north and south pole are facing each other, then the magnet will attract and then they just join together. But if you put it the other way around, with the north pole against the north pole, then you will experience the repulsion of magnet. This is just like how you saw in the video. Now let's try to drill a hole through one of the magnets on the right hand side. If let's try to drill a hole and put it through a shaft so that this magnet can rotate. And if you keep this magnet against the north pole of the magnet that is stationary on the left hand side, most likely the magnet on the right hand side will rotate because of the force of repulsion, and it will rotate along the shaft, and south pole will be facing the north pole, as you see in this diagram. So in this case, the magnet has rotated half a circle or half rotation, and it just stops at this point, because now in this orientation north and south pole are against each other. They don't repel, but they attract, and the magnet doesn't move. So somehow we have achieved half rotation using this mechanism. In order to have a full rotation, it would be nice if the south pole that you see on the magnet on the right hand side becomes north pole, and the north pole becomes south pole, right? So if there is a way you could flip the poles of the magnet on the right hand side, then it can continue spinning for another half a round, right? But these magnets are called as permanent magnets. That means the magnetism in these magnets are sort of permanent. You can't change the polarity of these magnets. North pole will be north and south pole will be south. So there's nothing you can do about it. These are examples of permanent magnet. Now there is also something called as electromagnet. What is an electromagnet? If you take, for example, a magnetic material like cobalt, iron, or nickel, or something like that, if you see if you see inside, the particles inside those materials will be like this. So they will just be in random directions, and they don't have any magnetism yet. But if you connect them, if you wind a coil around such a material and connect it to a battery, then the materials will align itself in one direction and it becomes a magnet, and this kind of magnet is called as electromagnet. Now in this case the electromagnet also has poles. It has a south pole and a north pole, and you can see that it is now a magnet as long as electricity flows through the battery inside the coils. Now an interesting thing is, if you flip the battery, as you can see in this diagram, the positive and negative terminals are flipped. The materials inside the electromagnet are oriented in the other direction. So now the north pole becomes south pole and the south pole becomes north pole, as you see in this diagram. So this means now we have achieved something using which the polarity of the magnet can be changed through electromagnet. You can reverse the direction of electricity, and then you can convert north pole into a south pole and south pole into a north pole. Now, before I proceed, a kind reminder to like this video, subscribe to the channel and press the bell icon. So this is helpful now in the other example that I was explaining. So here is the example. In this case, we have replaced the permanent magnet on the right hand side with the electromagnet, which we just discussed. So you will see here a battery being connected with a wire and a sort of a brush against this electromagnet material, and it can rotate along the shaft through the hole drilled at its center. When the electricity flows, the north pole is on the left hand side of this magnet and south pole is on the right hand side of this magnet. Now we also have the permanent magnet on the left hand side, what you can see here. Because of the like poles repelling each other, this magnet, the electromagnet on the right side, will try to rotate half a uh, circle or a half a rotation, and it turns in such a way that the south pole comes in contact against the negative terminal and the north pole comes in contact with the positive terminal. Now this means that the electricity is now reversed. The battery is not rotating along with the magnet in this case, right? So it is just loosely in contact. The ends of the battery is loosely in contact with the magnet. So when the magnet rotates half a circle, then the flow of electricity is also reversed. That means after the north pole has rotated and the south pole comes in the position of north pole, it again turns its polarity. So the south pole becomes north pole and north pole becomes south pole, and you have a force of repulsion again, and the the magnet on the right hand side can continue spinning. So in fact, if you try this, it will just spin continuously along the shaft, right? So that's how, that is the working principles. Now we can make this better by just having two permanent magnets and placing the electromagnet in between these two permanent magnets. Note here that the permanent magnet polarity is placed such a way that the the poles of the electromagnet always face the like pole of the permanent magnet. So this makes the force of repulsion double, because you have two magnets and on both sides there is a force of repulsion. So this makes the electromagnet, which is rotating around the shaft, to rotate with much more force than the example that I have shown previously. So this in essence is the working principle of the electromagnet. It is just a depiction in, as you can see in this sort of a GIF, you can see the exact principle that I just explained. So there is a electromagnet that rotates continuously in the in between two permanent magnets, and that's how motors work. Now if you take a look at a motor, a real looking motor, you will have several such rotating electromagnets, not just one. so that you have no chance of uh, a magnet not rotating fully and then stopping the rotation of the shaft, right? So that's why in a real motor there will be many um, electromagnets that rotate, and this part is called as the rotor. So in most motors, DC motors, the moving part is called as rotor, and rotor is the one that has coils, and that is a electromagnet. So it changes its north pole and south pole. It is connected to a battery, and that's the moving part of the motor. And there's also stator, which is also a permanent magnet, and the stator is in the shape of a curve, or is placed in such a way that there is a nice coverage around the rotor, so that there is a continuous force of magnetism that makes the rotor rotate. And then you have commutator, which is like a switch. So commutator, and then you have brushes, which make sure that the when the shaft rotates, when the rotor rotates, the brush is in continuous contact with the commutator, as you can see here. And finally, when the shaft rotates, because of this principle, this rotation is then passed on to the wheels and everything else in an EV. In the case of a fan, it is used to make the wings of the fan rotate, and blah blah blah. So that's how the motor works, in short. Now, not everything I said is like 100% scientific explanation. I'm just trying to explain it in such a way that a layman can understand. In in EVs, you could have one or two motors depending on all-wheel drive or a front-wheel drive kind of a model, and all of them work in the same principles. So that's how motor works. I hope you like the video. Thank you very much for watching. See you again in other episodes of Green and Clean YouTube channel.